Hello, it's me, Melissa Lake. I am going to complete lab number 3, experiment number 2, exploring cell size. And I have already completed the agar preparation. I have a picture for that I'll include in my submission. But it has been all mixed up with the nutrient agar, the bromethamol blue, and the saturated sodium bicarbonate. And this is the result about 36 hours later. It wasn't set completely last night, so I wanted to give it a little bit more time. So, I mean, it feels pretty solid now. So I'm going to go ahead and pop it out and see how it goes. But so I have all of those steps completed. And then I have all of my supplies here as well. The acetic acid, the vinegar, and then all of these mixings, if you can see that. And then I couldn't find the pad that was supposed to go under. I didn't have a safety bag really in my kit, but I have this cutting board just from my kitchen that I had planned on using, and it's okay. I don't know if the blue will tint it, but that's fine if it does. Ruler to measure it out, knife to cut it with. So let's see, the first thing that we have to cut is 1 centimeter by 1 centimeter by 6 centimeter block. Okay, so I'm going to use my ruler to measure that out. Well, I guess I have to pop it out first. Such a fun texture. All right. Like a very tough jello. Interesting. Oh, this is it. It didn't lay completely flat on this side. You can kind of see the light hits it, a little bit raised, but that's okay. I will do my best. Okay. So it said it's helpful to measure the 6 centimeter side of a block first. That would be this side. Oh, interesting. So it's kind of not a completely rectangular shape because it does get smaller as it goes up, but I would just measure from the bottom to get the 6 centimeters. Okay, so 6 centimeters long, 1 centimeter by 1 centimeter. And I'm guessing this is 1 centimeter. Okay, so it's a little bit over. So, measure. Just don't want to cut into it just yet. I want to make sure, because the other ones are 2 by 2 centimeters. And that's not quite 2. Okay, well, I'm just going to cut it this way then first. Okay. 1 centimeter. Whoa, yeah, it cuts like Jello too. Wow. Okay, so there is the 1 by 1 by 6 centimeter block. Just set that there. And then the rest, we have 1 by 1 by 1, 1 by 2 by 2. Okay. Actually, I'll do the by 2 one first, just in case. Oh my gosh. See why you're supposed to wear your hair back. Okay. Two. 2. And then 1. And by 1. That looks a little tall. That is tiny. Wow. I don't know why I expected it to be bigger. I guess since the mold is bigger. Okay. Okay, so we have our one tiny cube, 1 by 1 by 1. There. Let's put this off to the side since we're finished with it. And this is by 2 by 2. And so then we'll cut this one by 1. It's totally flat edges. All right. Okay, and then this is our 1 by 2 by 2 centimeter block. Then sure this one works. So that's by 6. By 1. There we go. Okay, and then this is our 1 by 1 by 6 centimeter block. So we have our blocks cut out. So it says once all 3 blocks have been cut, dispose of the remaining agar, use a solution or use a ruler to calculate the surface area, volume, and surface area to volume ratio for each block. Refer to the calculation section for assistance. Record calculations in table 2. It's by table 2 right here. Surface area, volume, and surface area to volume ratio. All right. So I guess we'll start with the little cube. It's 1 centimeter by 1 centimeter by 1 centimeter. There are 6 sides total. So the volume should be what? Just length times first all the area for each individual side, then multiply the area by 1 side. The total number of sides in the shape, the surface area. volume can be calculated with volume random length times width times height equals volume. Okay, so I guess we'll do volume first, and that would just be 1 times 1 times 1. So volume for the cube should just be 1 centimeter cubed. And so surface area is length times width. And because it's a cube, we can just times 6 since it has equilateral dimensions. So, okay, so length times width, 1 times 1 times 6 sides, 6. So surface area is 6 centimeters squared. Okay. And then, so for the rectangle, I guess that would be classified as a rectangle, maybe? I feel like I have to wipe my hands every time I touch those things. Okay, so that would be 1 centimeter times 2 centimeters times 2 centimeters. Okay. So that would just be 2 times 2 times 1, right? So volume equals 4 centimeters cubed. Yes. Surface area for this. Now, because these are different dimensions, we have to tally them up separate and then add them. So one side, and it would just be length times width, and then find each individual side. Okay, so one side is going to be 1 centimeters times 2 centimeters. And then we have 1, 2, 3, 4 of those sides. So that would be times 4. And then these two sides are going to be the 2 centimeters times 2 centimeters. And there's 2 of those. So just to make sure we're doing this right, 2, and then times the 4 sides. Oh no, you add the 4 sides up, right? Okay, yeah, so that good times. Okay, so 4 of the sides tally up to 8, and then the other 2 sides, 2 times 2, and then there's 2 of those, so times 2, 8. So the surface area for this one should just be, and then the 8 plus the 8, so that should just be 16 centimeters squared. I think that's right. Okay, so for the last one, there will be 1, 2, there will be 2, well actually let's do volume first, I guess. Volumes, just 1 times 1 times 6. 6 centimeters cubed. So then surface area, we have 2 sides that are going to be just 1 by 1. So that would just be 2. And then we have 1, 2, 3, 4. We have 4 sides that are 6 centimeters by 1 centimeter. 4 of those. So just to make sure I have this right. Okay. And then we add those two numbers together because that equals the total amount of sides. So 26 centimeters cubed. Did I do that right? Because on the example, it uses a cube. So it doesn't really give you an example of that, but it does say if the 3D structure does not contain equilateral dimensions, determine the surface area of each side using the equation above and then add the surface areas together to obtain the total surface area. Yeah. So there would be two that are 1 centimeter by 1 centimeter, so 1 plus 1, 2, and then there are 4 that are 1 centimeter by 6 centimeter. You add all those up, that's 24, so, and then you add all the sides together, so 2 plus 24 is 26 centimeters squared, right? I think I did that right. Okay. Okay. So 26 meters square, 16 centimeters, and 6 centimeters, and then 1, 4, and 6. Okay. So now that that is done, next step. Measure 150 milliliters of acetic acid or vinegar using the 100 milliliter graduated cylinder and pour it into the 250 milliliter beaker. Gently place all 3 blocks into the acetic acid solution. Okay. 16. So vinegar, and we need 100 milliliters. Or no, 150. My mistake. 150. Because what does this go up to? It goes up to 10 milliliters. I'll let the bubbles go down. Oh wow, right on the money. Okay. All right. So we'll pour that 100 in first. And then we need 50 more. And that's right there. I think that should be good. All right. Okay, so now, oh, just put them in. Okay. Right. But then we have to, I'm going to put a timer on my phone. It says let the blocks rest in the vinegar for 7 minutes. It says gently place. Alright, so I guess what is that? Oh, start. Okay. Timer start for 7 minutes. I feel like it's already starting to lose its color a bit. Yeah, around all the edges, it's a little more clear. Interesting. Okay. Let the blocks rest in the vinegar for 7 minutes. Observe As the blocks begin to change color from blue to clear, if any of the blocks completely change color, record how long it takes for complete color change to take place. Okay. After 7 minutes, remove the blocks from the vinegar solution. Pour the remaining vinegar down the drain. So let the blocks rest for 7 minutes. If any of the blocks completely change color, record how long it takes. Okay. So that's the only thing we really have to record. We just kind of have to watch it. Oh, wow. Yeah, it's on all the surfaces. All the surfaces are starting to turn clear. So it kind of looks like a glass rectangle or a glass cube that has liquid inside of it because of the way it's changed color on the sides. You know, there's on the rectangular one, the 1 centimeter by 1 centimeter by 6 centimeters, you can kind of see how on the long edges, because there's more area for the vinegar to get to, it's changing color. But then on the short edges, I think they are touching the walls a little bit, and so they're not changing. They are changing, but they're not changing as fast as the I don't know if you can see that, the long area. I'm guessing that's just because they're touching the walls and not a lot of liquid is able to get between there. Oh, well, maybe not. It's catching up. Oh, it's so neat. So I wonder, does the water turn blue, I guess? Does that change the color? Looks a little cloudy, but I wouldn't say the water is blue. Not yet, anyway. I don't know if I should be moving it around. It says let the blocks rest. So, okay. I can see that. So just rest. Yeah, you can tell now. The longer they sit in there, the more you can tell that the ends of the rectangle, because they're touching the walls of the cup, they're not getting as much vinegar in between the walls, so they're not, the color's not disappearing as fast on those sides. I wonder if any are going to completely change. You know, I wouldn't expect the 2 centimeter by 2 centimeter by 1 centimeter, I wouldn't expect it to completely change. Just because I figure it would take longer for the solution to soak up into it. If any of them change completely, I think it's going to be the little cube. Because even the rectangular one, the 1 centimeter by 1 centimeter by 6 centimeter, it's longer and it has, yeah, that's not going to change as fast. I think if any of them change completely, it'll probably be the cube. And I guess that would be because it has the smallest surface area. And it has the smallest volume, right? Yeah. So that makes sense. Yeah, it's really cool. I don't know. Very different. I wonder, when I take them out, I wonder if the centers of them are still going to be that, like, I guess this color. This electric, and well, maybe it's cobalt. I don't know what color blue this is technically, but oh yeah, they've lightened up for sure. Even in the very center, it's lightened up. It smells weird. It reminds me of something. I don't know what it reminds me of though. What does that remind me of? I don't know. It reminds me of something. Oh, okay. So my boyfriend is a PA, and he has these kits that they kind of have a texture like that. It's like a little block, and he practices sutures on this plasticky block thing, and I think that's what it smells like. Because I've played with those before, just to see if I'm any good at doing sutures, and I'm not. But yeah, I think that's what it smells like. That's what it's reminded me of. Oh, okay. 25 seconds to go. Yeah, none of them have completely changed, but that's really interesting. I wonder if I measured that wrong or if it's supposed to fit in there perfectly like that so we can see the difference of not having enough liquid get to the sides or not. I'm not sure, but I probably just measured them wrong. Okay, that was a timer that went off. So, guess we'll get these out. Does it say take them out? Let the blocks rest in vinegar. After 7 minutes, remove the blocks. Pour the remaining vinegar solution. Okay. And then gently blot the blocks dry. Okay, so I guess I'll use this. Oh, so weird. That one's really neat. You can really see the inside section there. Okay, and then I will pour that down the drain later, but for now it's just going to sit over there. Just put these over here. Gently blot the blocks dry. Cut them in half using the kitchen knife. For each block that did not undergo a complete color change, measure the distance of vinegar diffused into the gelatin cube as indicated by the color change. Okay. Ooh, so on the outside it looks like the paper towel has made some kind of indentions. It's like rubbing off, so it's able to kind of make a pattern because of the surface of the paper towel. But when I cut into it, it'll probably be clearer. Yeah. All right. It's probably sufficiently dry. So cut them in half. Does it matter? Should I cut lengthwise or? I guess this one doesn't really matter. Well, it could cut that way. Well, I'll just cut this way. I don't know why I expect there to be more resistance, but even when I was cutting the cubes out the first time, it just cut right through. Ah, so this is a rectangular one. Yeah, it didn't all the way to go all the way, but there's definite color change. I mean, when it starts out looking like dark like that. So that one was cut in half. Wow, the color's really disappearing. Yeah. I wonder if I should cut this length. Does it matter lengthways? I'll just cut them like that. So I would think that this one, the long one, would probably be the same as the little cube, right? Because it's, I wonder if at the edge, no, looks pretty much the same. It's so cute. Okay. Tiny. I think it's even disappearing while I talk. I don't think it's stopped changing color just yet. Because I swear there was more blue in this before, like right when I took it out, compared to now. But maybe not. I don't know. Okay, so they're all cut in half now. So what did it say to do? It's after 7 minutes, generally, but then cut them in half using kitchen knife. Measure the distance of vinegar diffused into the gelatin cube as indicated by the color change. Record that value in table 2. Okay. Time required for complete color change. Well, they didn't complete. None of them completely changed color. So I guess not available. Distance of diffusion. Let's start with the one first. So I would say about 1, 2, 3. About a quarter of a centimeter, 0.25. Yeah, it really is. 0.25, that's pretty exact. Okay. So and then this one. I was going to say which edge do we measure, but I guess it doesn't matter. It goes in the same all the way around. So let me measure this one too. Whoop. This one is almost the same. It's just a little bit more, honestly. 0.3. It's right at the third notch. Whoop. So slippery. One, two. Well, it's like 0.255. It's really similar. I mean, it's slightly more. I'm gonna say 0.3. It is. It is. Yeah. So I do wonder if it was supposed to be the same distance of diffusion. This one's almost completely gone. Okay. I think it really has kept changing because you can barely see it. It's almost gone. But I mean, I don't know how long it's been since the timer stopped. I don't know. Just report that. But okay, and this is the same. Yeah. 0.25. Interesting. So that's what I had guessed, that these two would be closer to complete diffusion. Obviously this one more than this one because this had the length and this was just 1 centimeter by 1 centimeter. And it's definitely not as blue. The color has gone way more on the ends, which makes sense, than it would in the center. It's more of a darker in the center, you can see. But this one, it's still pretty dark. So I wonder if they were supposed to be the same. Like all three of them were supposed to be the same. Or not. Well, I think, yeah, that was the last step. All right, well, that concludes this lab. I really want to know, though, was it all supposed to have the same distance of diffusion? Because this one, the measurement was just slightly different. Like a little bit, just a little bit greater distance. I wonder why that is. Or was I just not exact enough when I was cutting them? And that's why there's a little discrepancy. I don't know, but it's a weird texture. All right, well, that was the end of this lab. So I will go ahead and put this on YouTube.